observed that in nature, many things follow a certain pattern, such as the petals of a sunflower, grains of a maize, etc. Let us now look for some pattern which occur in our day-to-day life. Some such example is, Sachin put ₹100 into her daughter's money box when she was 1 year old and increased the amount by ₹50 every year. The amount of money in the box on the first, second, third, fourth birthdays was ₹100, ₹150, ₹200, ₹250, so on. In the example above, we have observed some pattern. The succeeding terms are obtained by adding some fixed number. And in this video, we will be discussing such patterns obtained by adding a fixed number to the preceding terms. That is the concept of arithmetic progression. An arithmetic progression is defined as the list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. That is, we get succeeding term is equal to preceding term plus fixed number. And this fixed number is called the common difference of the AP and is represented by the letter D. So, D will be equal to succeeding term minus preceding term. Remember that the value of D can be positive, negative or 0. In an elaborative manner, we can define a sequence A1, A2, A3 up to AN as an arithmetic sequence or arithmetic progression if the n plus 1th term of the sequence is obtained by adding a common difference to the nth term. That is, an plus 1 is equal to an plus d, where an plus 1 is the n plus 1th term of the AP, an is the nth term of the AP, and d is the common difference of the arithmetic progression. For better understanding, consider the following finite arithmetic sequence: 2, 4, 6, 8, 10. In this AP, there are 5 terms. Therefore, n is equal to 5. Also, A1 is equal to 2, A2 is equal to 4, A3 equal to 6, A4 is equal to 8, and the 5th term A5 is equal to 10. From this, we can easily understand that the common difference between each term is 2. That is, your D will be equal to 2. So, from this sequence, let us try to find out the n plus 1th term. Now, we have to add the common difference to the last term. That is, an plus 1 is equal to A6 is equal to A5 plus D, which is equal to 10 plus 2, we get it as 12. That is, an plus 1 is equal to an plus D. Now, let's quickly recall the concepts that we have already studied. Here we shall use the following notations for the arithmetic progression, where A is the first term, L is the last term, D is the common difference, N is the number of terms, Sn refers to the sum to n terms of an AP. Then the general form of an AP is represented as A plus D, A plus 2D, A plus 3D, and so on. Now, let A plus D, A plus 2D up to A plus n minus 1 into D be an AP. Then, the last term L is equal to A plus n minus 1 into D. Now, the sum to n terms of an AP is given by n by 2 into 2A plus n minus 1 into D. We can also write this equation as n by 2 into A plus L. That is the first term plus last term. Alright. Now, let us consider some examples to check the concepts that we have learned. Find the 10th term of the AP, 2, 7, 12, 17, so on. Here we have to find the 10th term, right? So, from the question, we can get the values of the first term, common difference. So, we get A equal to 2, D is equal to 7 minus 2, which is equal to 5, and N equal to 10. We know that the nth term of an AP is obtained by the equation AN is equal to A plus n minus 1 into D, and we have to apply this formula to this question. So A10 is equal to substituting the value 2 plus 10 minus 1 into 5, which is equal to 2 plus 45, and we get it as 47. So we get the 10th term of the given AP as 47. Now we shall look at some important basic properties of an AP. Consider an AP in its standard form, that is A plus D, A plus 2D. Now if a constant is added to each term of an AP, then the resulting sequence is also an AP. Second, if a constant K subtracted from each term of an AP, then the resulting sequence will also be an AP. Now, if each term of an AP is multiplied by a constant K, then again the resulting sequence is also an AP. If each term of an AP is divided by a non-zero constant K, then again the resulting sequence is also an AP. That is, uniform application of arithmetic operation on a given arithmetic sequence gives you a new arithmetic sequence. Now, let's have a look at another example. In an AP, if the pth term is 1 by q and qth term is 1 by p, then find common difference. In this particular question, we are asked to find common difference. Right? We know that the general term of an AP is an is equal to a plus n minus 1 into d. So from this we can write AP is equal to a plus p minus 1 into d. Similarly, AQ is equal to a plus q minus 1 into d. That is, AP is equal to a plus p minus 1 into d, which is equal to 1 by q, which is given in the question. Mark it as equation number 1. Now, AQ is equal to a plus q minus 1 into d, which is equal to 1 by p, and mark it as equation number 2. Now, we have to subtract 2 from 1. We get p minus 1 into d minus q minus 1 into d is equal to 1 by q minus 1 by p. Again, p minus 1 minus q plus 1 into d will be equal to p minus q by pq. From this, p minus q into d is equal to p minus q by pq. From this, we get d is equal to 1 by pq. So far, we have been discussing the basic properties of arithmetic progression. Now, it's time for us to understand what an arithmetic mean is. We will also see how the concept of arithmetic mean can be applied in the formation of an AP. Suppose the two numbers, let 5 and 7 are given, and we can insert a number 6 between them so that 5, 6, 7 is an AP. And such a number 6 is called the arithmetic mean of the numbers 5 and 7. Note that in this case we have 6 minus 5 is equal to 7 minus 6, which is equal to 6 is equal to 5 plus 7 by 2. Now, is this interesting? Right? Arithmetic mean is the simplest and most widely used measure of average. It simply involves taking the sum of a group of numbers and then dividing that sum by the count of the numbers used in the series. We may also interpret the AM of two numbers A and B as their average. That is, AM of A and B is equal to A plus B by 2. For example, AM of two numbers 4 and 16 is 10, and we can thus construct an AP 4, 10, 16 by inserting a number 10 between 4 and 16. Now, a natural question arises. Can we insert two or more numbers between given two numbers so that the resulting sequence comes out to be an AP? Let's take the two numbers 3 and 12. We can insert another two numbers 6 and 9 so that the resulting sequence 3, 6, 9, 12 also becomes an AP. Similarly, we can insert 2, 3, 4 between 1 and 5 so that 1, 2, 3, 4, 5 also becomes an AP. Generally, we can write it as Given any two numbers A and B, we can insert as many numbers as we like between them such that the resulting sequence is also an AP. Let A1, A2, A3 up to A and B the n numbers between A and B such that A, A1, A2, A3 up to AN, comma B is an AP. Then the common difference in this case will be D is equal to B minus A by n plus 1. The n numbers between A and B are as follows, where A1 is equal to A plus D, which is equal to, substituting the value of D, we get it as A plus B minus A by n plus 1. Similarly, A2 is equal to A plus 2D, the second term. So, we'll get it as A plus 2 into B minus A by n plus 1. Similarly, A3 and An will be A plus nt, which is equal to A plus n into B minus A by n plus 1. Let's check this concept with an example. Insert 5 numbers between 4 and 22 such that the resulting sequence is an AP. Here we are asked to insert 5 numbers between 4 and 22 such that the resulting sequence also forms an AP. So for that we have to apply the concept that we have learned in the arithmetic mean section, right? Let A1 to A5 be 5 numbers between 4 and 22 such that 4, A1 to A5, then 22 are in AP. Then the first term A is equal to 4, the last term B is equal to 22 and n is equal to 7, the number of terms. Now we know that n the term an is equal to a plus n minus 1 into d. Therefore, 22 is equal to 4 plus n minus 1 into d. From this we can solve for d. We get d as 3. Now, what will be a1? a1 is equal to a plus d. First term is 4 and the d is 3. So, 4 plus 3 is equal to 7. A2 is equal to a plus 2d, which is equal to 4 plus 2 into 3, which is equal to 10. Like that, we can find a3, a4 and a5. So, a5 we get it as 4 plus 5 into 3, that is 19. So, hence these 5 numbers between 4 and 22 are 4, 7, 10, 13, 16, 19 and 22. Hence, this forms an AP. So far, we have discussed all the basic concepts related to arithmetic progression and its properties. There are other types of sequences such as geometric progression, which we will discuss in the coming video. Now, let's do a quick recap of what we have learned.
Manorama Horizon. Learning made simple.